next we have Bolke talking to us today. Bolke is CTO ING Wholesale Banking Advanced Analytics. Before joining ING in 2008, Bolke worked at the 2004 Summer and 2006 Winter Olympic Games, managing the technology, communication, and data requirements for all news and media feeds at 2 large event locations. Bolke has also run his own startup, commercializing multi-touch technology. In his spare time, Bolke is a guest lecturer at the University of Amsterdam, a fun father to Mattia and Timo, and can be found surfing, obstacle running, or taking in a museum when the opportunity arises.
Absolutely.
Welcome.
Thank you very much. Which one is mine? Oh,
This one.
Yeah, okay. That's my name, indeed. Hello. So I've got a couple of very boring slides. So I try to enlighten you a little bit with my presence here. See if that works out. Let's see if that works. Today I will talk about elegant data pipelining with Apache Airflow. I'm going to be borrowing some of Max's slides that he did in the past, and also Fokke, because partially I've done this talk at Ifpy Data Amsterdam in early spring, I think it was. But it's continuing a little bit of the thoughts behind that. That's interesting, I think. Oh, okay. I can work with that, no problem. Well, I am a Airflow committer since a couple of years. Somehow I got introduced to Airflow by a friend of Fokke, actually, and he said, "Yo, Airflow is great. Do something with it." Okay, let's do something with it. And I found out that a lot of the security parts were not in place. And as I work for a bank, that kind of had to be in place and to do the standard stuff. It's not perfect yet, as you've just found out from the previous talk, isolation, DAX, these kind of things. But it kind of got to a workable state for us where we can manage the things around that. In the meantime, the department I work in actually grew to like 55 people now and is going to be growing to 320 people now. So I'm a little bit more distant from the real work, I guess. But I still have a love relationship with Airflow, so I do have a look at it. But today I will talk about elegant. And what does elegant mean? Well, in terms of Airflow, that basically means that you'll have to have reproducible pipelines. So things that are deterministic and idempotent. This is actually coming back quite often in any of the talks that you see basically the committers doing. And you see it also as one of the main blocking items basically with people deploying Airflow when they start out, because the deterministic and the idempotent part doesn't really enter the first thoughts of people. They just start building a pipeline, and then they find out, going into the future or backfilling things gets kind of difficult when you don't have idempotency. But that also introduces the next point right away, and that's about creating future-proof pipelines. And that's for backfilling, but actually also versioning, which gets important for the main subject of this talk, which is also, or let's say the underlying thing there, it's about, where I talk about lineage. It also means that you need to be robust against changes. So you want to have easy changes like adding or removing or changing tasks. And if the tasks are not idempotent, for example, that makes it kind of hard to do these kind of things. And then finally, where in this case I'll focus a little bit more on in this talk, is about clarity. It's transparency where data resides, what it means and where it flows. For this, we borrow from functional programming, because maybe you've seen the items I just put on the screen a little bit earlier, is that functional programming is that you model operations as a mathematical function. And this is maybe where we started from just machine, like doing bits and bytes, where we had, and then went to assembly and then had procedural languages like COBOL, still being used in my company. And then finally we moved to object-oriented, and then we say, oh, well, we've evolved and went to functional programming. So this means, oh, there we go again. that transformations should happen as a pure function. So given a mathematical equation or a function, if you put something in, you always want to know the exact what you're getting out. So it's defined input and output. This is also easier to reason about and to unit test for obvious reasons, because it's deterministic. It also means that there is no side effects. So for the ones that are not entirely familiar with this, it's like, okay, you see the first example where you have like a counter started in a global space, and you'll add to that counter with a impure add one. So that has a side effect that it's outside of the function that's being changed. So if I would put a variable in, which it doesn't take right now, that variable could change on the way. While the next example, with the good example, actually is a pure add one. It just adds one to the variable or the parameter that you put there. It's very simple. It gets more complex, obviously, when you do more complex functions. But I think it shows the point. Going to data, this means that you want to be idempotent in your actions. So you want to set a user to active with a deterministic setting, like set the user to active, in this case to false. If you said it's not active, you might not know what the outcome actually is, which you're getting into your data. So this is kind of important. So imagine in this case that you would pull in data through from CoinDesk in this case, and to do this properly, you'll have a execution date with it, and as a start and an end execution date. So this means that you can go back in time, yesterday, for example, with that execution date, and pull in the data for that day. If you do that in the bad example, you just get the current price, because if you would do that yesterday, you would get the price for today. So that doesn't really create the idempotency. Maybe if you want to imagine you need to do a mortgage calculation in banking, you want to be able to reproduce that mortgage calculation because your customer might ask you for an explanation how you got to that answer. So if you do that on your current modeling or your current data set, that might give you a different answer than what you got today. So this is important in multiple circumstances. So if you get to that, the data needs to be immutable as well. So you never append to partition, but you override it. This means you fully recreate that data for that data for the time frame you created it in. It also makes things easier to do them in parallel. So you can just schedule one day through the second day, the third day, the fourth day, or if you can do it by week. So the example that's there is obviously that you override the cryptocurrency table with an execution date to it, and you set the right things to it, and then and make sure that you do it by days in this case. Again, this is the final. It's the final partitions. You'll see that's in your raw data. You can say, oh, raw sales. You get to fact sales and you get to aggregated sales, but they all retain the same execution date with it. So you can always go back into those partitions and find the data again and reproduce it if needed. So if you had a task to do a different kind of transformation that you need, you can reproduce it for that part. Now we get to the somewhat more exciting stuff, or let's say early works that are to a certain extent working in 1.10 plus. And this is where it gets kind of bleeding edge, and we're still working out. And I'm actually inviting you guys to provide some input here to see what the direction should be. Because this is a bit of my thinking, what we see in the company happening, and the requirements, especially in the European GDPR requirements. That we see, okay, we want to, and also discussions on the mailing list about being able to to do data flows instead of just sets of tasks. But integrating with the task base, what the Airflow basically is how to make it like a nice hybrid thing maybe, and not a Frankenstein, is something we still need to work on. So for example, think about data as inlets and outlets in this case. So basically you do a transformation on the data sets, which is your inlet. You'll create an outlet. In this case is another table maybe. So then you would be able to create templates for your operators, like the one that's actually on the screen, that says, okay, I'm just picking this up from the table name that's being specified in the inlets, and then you create that partition like you just shown actually just before, and then you can do that transformation, just fully templating it. And we had a bit of a discussion with Max earlier, so he was a bit surprised that you could do that on a instantiation of the actual operator, instead of that it's like hard coded into the DAG. Because that doing this at the instantiation of it makes it a bit more flexible. Because then through and then we're actually using XCOM to communicate to the next task downstream what the settings are, what the inlets are to the next operator. If we would adjust the operators to take care of, to actually understand what the inlets are, you can actually do like where we have the HTTP operator just calling out to one source and to one destination. You could actually say, okay, I have a multitude of inlets, and I'll get a multitude of outlets because of that. And that can be done in one operator suddenly. Makes things more scalable, and you can get better modularization of the flows that you're creating. So you can then change the code over time. It says previously, but previous DAG runs can then be repeated with new code. And data can be repaired by rerunning the new code, either by clearing tasks or doing backfills. It gets down to the idempotency again. And reproducibility is critical in this case. This is important for a legal standpoint, like I just explained for the mortgages. And for banking, at least on our case, we need to be able to explain to our customers how we get to the certain decision. And I think it even gets more important in other areas as well, because you have fights with either how things work and where you made a mistake, because human beings make mistakes even in the data science side. And it's also to keep sane in this case. So what kind of things can you do that for that? Clarity by lineage. People often think that lineage is regulatory driven only, so from the auditability side. But it's actually also interesting from a data engineering side and data science side, because it answers the following questions for a developer, like, okay, what is the latest version of the data that I actually need? Maybe I want to have an earlier version of that data. Does it exist? Can I go back in time? Maybe with versioning of the data that you do, because we might want to be able to version models, but we then also need to version the data. So as we've changed maybe the DAG to rerun a new or add a task to it, we still might want to be able to go back in time and get the old data set from there. The question is also, obviously, where did I get the data from? All the transformations that we nowadays do in our companies, we might want to backtrack on them and see where did it actually start. And what's important is where do we store this kind of information? Because Airflow itself is not maybe the right place to do these kind of things, because these graphs are getting really, really big. And Airflow might do that on the DAG level and show you, what the data flow is. But going back in time in that way and the UI is maybe not the right thing for Airflow to do. And maybe you want to integrate with other systems there as well, and not just Airflow. Because your data scientists might do things outside of Airflow, obviously. So there's like rudimentary support in, I've got 5 minutes, like that. Ah, that's quick. I have to be faster. So there's rudimentary support in Airflow for supplying this kind of information to, in this case, Apache Atlas. And I don't know if you spot the problem with this picture, because this is a data flow. I don't know if anybody recognizes the issue with this picture. And Focko, you can't tell because I told you already.
What's your finishes first?
What's that?
Race.
A race? No, it's not a race in there. No. Anyone else?
I don't think you can see it from the beamer. It's a bit clear.
Can I zoom in a little bit? Oh my God. I'll go down again. Okay, I'll explain it then. No worries. It's not an idempotent DAG because it starts at a source, and I've run this DAG basically twice with a different execution date, but the source and the destination stay the same. Basically, I would expect kind of a straight line, or maybe two in this case, because the initial source needs to be showing up twice, and the destination needs to show up twice as well. And this immediately shows, obviously, where you can maybe gain maturity eventually in your own DAG pipelines and your pipelines by having this kind of visualization, and then you'll start understanding why it's getting important. So let's dive in a little bit too quickly then, because I have 4 minutes left. Imagine that you're using a machine learning models that need conversion rates for your currencies. Just I've shown you before quickly. These you use for advice to your customers. And for your business, it is important that you're able to explain to your customer how they got to a certain decision. Basically, the reasoning I gave you just a minute ago. So our DAG consists of 3 tasks. Download currency data from the web, run the machine learning model in Apache Spark, and drop the data in Apache Druid for OLAP. So simple definition of DAG. Wouldn't go there. I expect you to understand it, or just grab some examples if you please. Then, what's new? You can say, okay, my inlet is a file from from CoinDesk, getting the right data from there. It's being templated with the execution dates, and the outlet is okay. I want to put it somewhere in an S3 bucket at another place with the execution date and a version associated with it. And the amount of versions that I want to have is 5. So my first operator, or my operator basically exists, okay, I use these inlets and the outlets, and that's maybe difference from earlier, is that you, instead of using source and destination, I use the inlets and the outlets. Then finally, I get a second, I get an outlet that creates the prediction, or contains the prediction, and the Spark submit operator receives that and determines the inlets automatically, because it receives those through XCOM, because the outlet from the previous one specifies, okay, that these are the inlets to the next downstream operator. And from the outlet, in this case, I have the Spark submit operator, I tell the Spark submit operator what it needs to do. You could imagine if there's a bit more or better integration with Spark eventually, for example, that is even not required, because Spark will deliver this information somewhere. It's kind of hard to get at the moment. I have 1 minute. Jeez, I'll be faster. I won't talk faster. I'll just take a little bit more time, maybe. And then finally, we drop it into the Druid itself. I hope that's kind of clear. The example is there, and then you get the results. That is this. Now I get a straight line, because if I rerun this one again, I will get a new date associated with it. Now let's imagine that you can tag the data. So imagine your S3 bucket where you put that first set of data in is being tagged. This contains personal information. Then we could trigger a DAG that sets and set the inlets on basically on the triggered DAG. That instead of is more generic, and there's a bit of an error in the slide, but that sets or understands that it can obtain the tag from the metadata of the data or from the metadata. Then you can have a generic DAG for any kind of PY data that, if it's in a table, that just specifies on this columnar level, I have PY data, and I can remove it. So probably not entirely right because it doesn't work yet, but imagine that you can, for every inlet that you get, you have a kind of cleaned table set, and that you through all the columns, through the cleaned columns that you still want to have in that data set, you can run through that. And then you can put this like as a module inside any kind of pipeline, and it will still work as long as the metadata is there. Got very close. So I'm concluding this one with, obviously build data pipelines that are idempotent, deterministic, have no side effects, use immutable sources and destinations, and don't do update, upsert, append, or delete. Thank you very much. Hope you enjoyed it. A bit of bleeding edge. Can I take 1, 2, 3 questions, something like that? Anyone has a question?
What do you mean by versions in your operator? Is it max 5 versions?
Well, if you would rerun at that moment, you would create a new version. So let's say I'm getting that CoinDesk data from today. If I rerun it again, I get a new version, of today. In this case,
You want infinity, right?
you could do infinity, yeah. So I wouldn't expect you to do infinity, but that's kind of gets a bit difficult. But yeah, you could do that. So depending on your business needs, you should be able to specify how many of these things you need, because as I explained, you can add a task to the DAG that will generate a new version for that execution date. Obviously, you want to be able to go back in time through in other reasons in this case. Anyway, yeah, that's it. I should. Do you want me to repeat the question? For the recording. Oh, so okay. I need to backtrack that one as well. So the question was why versioning, right? Why it was a max versions. Okay. So yeah. So this is a bit. Why is it max versions? And the explanation was, okay, this is a business requirement. How far back in time on a particular version you want to go? Anyone else? Yep.
In the example you showed there for the backfill, you still have the execution date as the macro. So have you thought about using like start date, sort of like not start date pipeline, but start execution date and end execution date as a sort of macro, new macros? Because what we found in our use cases is that in some cases, user will have like run a pipeline every day, for example, for ETLs, and then they may have a look back date, so they compute like 3 days just in case they miss any data points. But when you do the backfill, really you don't have to look back for 3 days. So they'll write a query look like between like DS and DS minus like a look back date, like 3 days. So we feel like have a macro to replace that execution date, replace that with like start date and end date. Turns out to be more efficient. User can write more backfill compatible pipelines.
Okay. To be honest, the question got a bit complex. Did
I make myself clear?
Kind of, but and I don't know if I'll be able to fully answer it, because basically this is early thoughts which we're trying out, So basically open to these kind of things and get back on the mailing list, for example, on these kind of IDs while implementing it, and we can just do it. I mean, all the templating that is currently working in Airflow is also applicable to the inlets and outlets, so it's not separated in that way. So you should be able to specify everything you want if it's already available.
All right, thank you.
Final question? No final questions? Well, then thank you very much, and then up to the next speaker. Thanks.